The tilted distribution pole, as I saw observed this tilted distribution pole in my locality. What might be the mechanical danger chain? The stage 1, immediate mechanical shift. Uneven tension in the conductors. As the poles are tilted, so the uneven tension in the conductor are going to create. What might be the cause? Tilted pole changes the pull direction, and hence what is the effect which we are seeing? One side tightens and the other side sags. What is the formula which we are going to see? The force component due to tilt. T horizontal is equals to T into sine theta, where T is the conductor tension S and which has the value about 1200 Newton. We will see that how this 1200 Newton came. Theta is equals to tilt angle is equals to 15 degree. So TH, that is the horizontal tension, is equals to 1200 into sine 15 degree, which is approximately equals to 311 Newton. This extra 311 Newton of sideways pull adds to base and the next pole. Thus, it needs to fix very immediately. So let's calculate, as I said earlier, that the conductor tension, how the value 1200 Newton came. We are going to use the standard sag tension formula, assuming parabolic catenary approximation. Thus, the formula is T is equals to WL square by 8S, where T is the tension in Newton, W is the conductor weight per unit length, that is Newton per meter, L is equals to span length, that is in meter, S is equals to sag, which is also in meter. Let's now use the realistic distribution line values. Conductor type, we are going to take ACSR. Weight W is equals to 11.8 Newton per meter, span L is equals to 40 meter, sag S is equals to 2.0 meter. Thus, using the same formula as we just discussed, so this tension is approximately equals to 1180 or 1200 Newton, which is the value we previously used. The second one, that is an uneven sag in the conductor. What is the cause? One side has more tension and the other side is less. What is the effect of these? Clearance from ground reduces, and which may lead to electrocution of wire risk. Actually, the capacitive charge in case of the distribution line is very less, and hence the electrocution of wire risk increases. And what is the formula for finding the sag? Let's see. S is equals to omega L square by 8T. Omega is equals to weight, or W you can say, is equals to 12 Newton per meter. L is equals to span, which we are taking about 40 meter. Span is the distance in between the two poles. Normal tension is equals to T is equals to 1200 Newton, as we just used before. S normal is equals to 12 into 1600 by 8 into 1200 is equals to 19200 by 9600 is equals to 2.0 meter. If tension reduces to 1000 Newton, which is because of the tilted side, so S tilted, that is a sag, tilted sag is equals to 12 into 1600 by 8 into 1000 is equals to 19200 by 8000 is equals to 2.4 meter. This 40 centimeter extra sag may break the clearance limits, and the norm is 5.5 meter. So it also needs to fix very immediately. The second stage, that is a structural and hardware stress. Pole-based bending moment increases. What is the cause of this? Lateral force acts due to the tilt. As the pole is tilted, so there is a lateral force acting on it. What is the effect of that? Foundation cracks or pole breaks. The foundation of the pole is going to break. And how we are going to find that? Is there any formula? Yes, there is formula. M is equals to F into H, where F is the horizontal force is equals to 311 Newton from above, as we discussed. H is equals to the conductor height from the base is equals to 8 meter, which we are taking. M is equals to 311 into 8 is equals to 2.88 Newton meter. Actually, what is M? M is the moment. This is enough to crack or loosen the poorly anchored base. This also needs to fix. The cross arm and insulator misalignment. What is the cause of this? Full angle changes. Insulator tilts, and the effect which you are going to see is flashover risk increases. Of excess torque on cross arm. What is the formula? Let's see the formula for this. Tau is equals to F into D, where F is equals to 311 Newton, D is equals to 0.6 meter, arms offset. We are taking this distance for the arm offset. Tau is equals to 311 into 0.6 is equals to 186.6 Newton meter. Twisting stress on the cross arm bolts and insulator neck. The stage 3, that is the systematic risk and long-term effect. What is this stage is saying? Pull on the adjacent pole. What is the cause of that? Diagonal load now acts on the neighbor pole also. Effect progressive tilt or sag in next span. So here what is going is force transmitted is equals to same as horizontal. F is equals to T into sine theta is equals to 311 Newton. Neighboring pole slowly starts taking unequal load. Now the neighbor pole also start taking the unequal loads. Priority. We have to monitor that and fix in inspection. Let's go to the next point, that is span, stretch and sag mismatch. The span is going to stretch and the sag is going to mismatch in between the different poles. Cause pole leans, effect span becomes diagonal, effect electrical effect, GMD or inductance or sag change, as we saw in the earlier video. Effective span, L dash is equals to under root L square plus H square is equals to under root 40 square plus 0.7 square, approximately equal to 40.006 meter. Difference in sag or spacing, which is minor phase imbalance, but not dangerous alone. This is very less gravity as compared to that of the above we have discussed. If we left uncorrected, a small tilt today creates an unbalanced wire tension tomorrow, dangerous sag next week, and a cracked pole next storm. The real load is not on the pole, it's on the conductor. So conductor is the main thing where we have to put stress upon, because conductor is what handling the current through it, and which is the main role of these pole to carry upon.
I want to add more factor of safety, FOS. Actually, it tells us how much stronger our system, that is in this case our pole or tilt pole is So for the formula of FOS, factor of safety is equals to ultimate strength by actual applied load, as you know that, where the ultimate strength means the maximum the material or part can bear, and applied load is the load, force or moment currently applied to tilt. So FOS for a pole base, FOS for a cross arm torque, FOS for conductor tension. So these are the values for that. But let's now calculate for FOS for conductor tension. This depends upon the conductor breaking strength versus applied tension. Example, ACSR dog conductor. Breaking strength is about 9300 Newton, whereas applied tension is about 1200 Newton. Thus, FOS of a conductor is equals to 9300 by 1200 is equals to 7.75. It is very safe, but only if vibration, wind and lightning does not strike it. But we need to care that our pole must not be tilt. If we go through the FOS for cross arm torque, it is about 2.68. For pole base FOS, it is about 2.41. If the value goes below 2, then it is a very dangerous condition. Thus, despite of the fact that FOS for the conductor tension is very larger than that of the two, we have to make our pole to be erect and not tilt. Thanks.